Section 12.4, Infinite Series. So until now, all the series and sequence we've had have stopped at a specific number. Now they're going to go on forever. So you're going to see this plus ... which indicates they keep going. If we write it in the sum notation, you'll also see that that top bound is infinity. So the first thing we're going to look at is something called finding a partial sum. So the first partial sum is just the first term. Our second partial sum, basically I take terms 1 and 2 and add them up. The third partial sum, I take the first 3 and add them up. The fourth partial sum, I add up the first 4. The fifth partial sum, I add up the first 5, and so on. So that's just what we mean by a partial sum. Now in this section, most of our problems will be a geometric series, as we've seen before. And so it'll be in the form of a plus ar plus ar squared plus ar cubed and so on. And our sum is going to be a over 1 minus r. However, we have to be a little bit careful. That r value, if it's between -1 and 1, it will converge, and that will be our sum. However, if that r is not between -1 and 1, our answer is going to be that it diverges. Now for these problems, we generally will just be given the first few terms in this series. So just as before, we'll have to identify a and r, just like we did in section 12.1, I believe it was. So here a is the first term, which is 3. Remember, r is the second term over the first term, or the third term over the second term. Those should all give me the same value. Here I get 1 over 8. Since 1 over 8 is between -1 and 1, that means we will converge. So let's use our formula, which gets me 3 over 1 minus an eighth, and then I get that this then converges to 24 over 7. Similarly, for my next problem, that first term, 3/4, is my a. Again, r is the second term over the first, or the third term over the second. Again, those should all give me the same value, and here I get -3 over 4. -3 over 4 is also between -1 and 1, so that means this does converge. So I'm able to go ahead and use my sum formula, 3/4 over 1 minus -3/4. And as always, I'm lazy, I use my calculator, and I got 3 over 7 for my answer. My third example here, again, a is the first term, which is 1. R is here, since you can see that 1.1 to a power, it's hopefully pretty clear that 1.1 is my r value. Now 1.1 is bigger than 1, so it is not in this interval -1 to 1. That means this diverges. We don't need to do anything else. My answer for this type of problem is simply the series diverges. That's pretty much the only types of problems that we will see, so we will need to know this formula, and again, we will have to be careful because we will sometimes have series that diverge.